two properties, that was last week. And then here is, you already did this one. These two are called inverse operations. Now just remember, if you go to my picture over here, guys, on the whiteboard, here is exponential, y equals 2 to the x. Here is a logarithmic function. Notice that's base 2 up there. So is this. If the bases are 2 and 2, exponential versus logarithmic, they're just what? They're inverses. How do we know they're inverses? Because they're reflections over what? Yeah, look. Boom, boom. Straight across, straight across, straight across, straight across. I mean, it would reflect perfectly. And because of this, there's these inverse properties, which says if you have exponential base A raised to a power that happens to be a log, and it's base A, what we can do is cross them out because they're inverses. The answer is what? M. That's what it is. If you don't trust it, how can I make it easy for you? 10, raise it to the log of 100. I think you know the log of 100, don't you? Isn't it 2? Because it's 10 to the what? Second gives you 100. So really this says 10 what? Second, yeah. What's 10 squared? 100. So guys, couldn't I just do this? Cross them out and the answer's 100? I mean, I can just do that. I don't have to go through this mess. That's what they're trying to tell you. They're also trying to tell you if you have log base A of any exponential number, base A, cross them out, the answer is what? In this case, R. Okay, don't know what I quite said, I'll just do it again. Log of 7 to the third, base 7. Hey, doesn't this make sense? 7 to what power is 7 cubed? Doesn't it have to be 3? But you don't have to think that hard. Just knock out the bases. They're the same. The answer is what? 3. That's what this said. Those were old properties. I hope I didn't surprise you. Here comes the new properties, and here's the big one here, and here. Okay? When it comes to logarithms, if you see multiplication, multiplication can be split into what? Addition. Okay? So what I'm saying to you is this. You see log of 12? If I knew log of 12, do you guys agree? 3 times 4 is 12, right? Okay, so log of 12 is really log of 3 times 4. But log of 3 times 4 is just simply log of 3 plus log of 4. Multiplication can be split into 2 logs as long as you do what? You add them. Okay. That's going to be kind of hard for you to remember, so how about coming over here? Look at this. Because these are inverses, do you guys remember this? When you were in 9th grade, your teacher said x times x, exponents. What do you do to the exponents to get the answer? You add them. But when it comes to logarithms, if you're adding 2 logs, what do you do to the numbers, A and B? You multiply. These 2 things are almost the same, it's just that they're inverses. So here, we add, but here, we multiply. So they go together, is what I'm trying to say. That might not help you at all. I just said something that didn't make sense. Log of 10 times log of 100. What would you do if someone asked you that on the test? Log of what? 10 plus what? Log of 100. And I bet you know the answers to these because these are both base 10. 10 to what power is 10?
1.
10 to what power is 100?
2.
Answer? 3. What is this? That's just 1,000, isn't it? Log of 1,000. Oh, what's the log of 1,000? 3. 10 to the third is 1,000. It works. It's kind of nice to have properties because sometimes you can't figure out the answer. But with a property, you can figure out the answer. Okay, now when it comes to division, division will be what? What will it be? Subtraction. And if you think about it, when they told you to divide two exponential problems, x to the a over x to the b, what did you do to the powers?
Subtract.
You subtracted them. That's what you did in ninth grade. Well, with logarithms, log minus log go back to division. Division and subtraction go together. Addition and multiplication go together. All right. Here's a quick example down here. Log of 12. Base, any base, doesn't matter. Well, the number 12 is really just this number, correct? 12 divided by 2. Right? Yep. Okay, but, did I say it wrong? 24 divided by 2, sorry. But 24 divided by 2, you can break that apart into what? Log of 24 minus log of 2. Did you notice where the 24 went? First or second? Okay, so the numerator goes what? And the denominator goes second. That's how it works, okay? That's all it is. Any questions? All right. Here's another property that comes in super handy when you're solving log equations, exponential equations. It basically says this: if you're taking the log of any number raised to a power, where can the power go? Right in front, exactly. That's where it can go. Okay. Before I look at this, just do this, please. What is the log of 10 to the 5th? This is base 10 now. Who knows the answer? Say it, Zach.
5.
Everybody agrees 5? Okay. Using the property says you could put this where? Out in front and call it 5 times log of what? 10 base 10. Now answer this question. What's log of 10? 1 times what? 5. You told me the answer was 5 up there. It's still 5. Even by using properties, I still get 5. So the property works. If you knew the answer, would you have done this? No, nobody's going to do that. But I'm trying to prove that it does work. Okay, here's a couple examples right here. Log of 5 to the 4th, base 6. Where's the 4 go? Out in front. The natural log of 5, that's raised to the x power. Sorry, just kind of got way too far over. Where's the x go? Out in front. There you go. By the way, when I say ln, what base am I in? I'm in base E, base E. I don't write base E, but I want you to know I'm in base E. How many properties are there? 3 new properties. They are right here. These 2 and this one. Okay? Now your job is to take that problem, and my instructions are all messed up here. I think my instructions are way down here. Yep. Okay. So, all right. Use the properties we discussed to expand that one. Take log of 2x cubed y divided by z cubed. Take it and expand it. Which means, expand means, give me multiple logs, like 2 or 3 or 4 or 5. Think about it. So guys, when you do these problems, everybody's always saying, well, what do I do first? What's the first thing I'm supposed to do? When you expand one log into 2, 3, 4, 5 logs, think GEMDA's order of operations. What would you do first if you put numbers in? If you put something in for X, Y, and Z, what would you do first? Tell me if you knew this number was 5, this was 3, this was 10, what would you do first? The exponent would be first. Okay. Then what? So, okay, I'll go like this. Exponent, then what? Which, yeah, you'd multiply up top, right? Then what? Then division, right? Does everybody agree with that process right there? Exponent, multiply, divide. Guess what? When you expand, make it longer, go the opposite direction. Go this way. Okay? So this is it's like this is first, second, third. No, go this way. So get rid of this. Get rid of the division first. So if I see division right there, I'm going to change this to what? Log of 2x cubed y, right? 2x cubed y, whatever that is. And then what? Minus log of z squared. Got it. Does that make sense? I'm going backwards. I know the order of operation tells me how to evaluate it, but when you expand logarithms, you're going backwards. Go this way. Okay, this is done. How about multiply? Where do you see multiply? Right there. Log of 2 times log of this times log of this. So let's split this. How many numbers am I going to multiply up here? 1 times another one times another one. So you would have to split this into what? 3 logs. Log of what? 2 plus log of what? X cubed plus log of what? Y minus log of what? Z squared. Okay? All right, did this. I took the multiplication part of it right there. I worked with that. Now it's just these stinking exponents that are in my way. Where do I put the 3? In front. The 3 has to go here. Where do I put the 2? In front. There it is. And now just go erase this. Whoops. And this. And you call that your answer. Sorry. It's a plus. Okay. Yes? So, did you listen to me? Expanding, think of it as it's just order of operations backwards. That's kind of the order you go in. And for some students, it just totally makes sense. So whatever, you don't have to do what I just said. But if you get kind of lost, think of it that way. Okay? Okay, this one's what? Give me 1, 2, 3 logs. Give it to me as a what? I just want 3 logs to become 1 log. Okay? Now this is it's kind of hard to explain how to do this, but I'll let you take off for a little bit. So where did you start? Yeah, go ahead, Zach.
I started with the addition.
You started right here. You took off right away.
Yeah.
These two? Okay.
I started.
The only thing is, see, to me, this one, when you think of it, this one, Jim does, now you got to go the correct direction. So if there are exponents to be taken care of, I do that first. So I would say that 2 belongs where?
Above the A.
And this 4 belongs
Above the B.
above the B. So log of 3 plus log of what? A squared plus, no, sorry, minus 4 log of what?
The log of B to the power of
Oh, B4, yep, you're right. B4. Okay. Good? Okay, so I mean, I'm thinking, oops, that's done. Done. Okay, if there's multiplication, and the only way you're gonna know if there's multiplication is if you see addition. I take that whole thing back I just said. Don't worry about it. Would you please go in order now? Left to right, you got this, right? So those two make what? Yeah, that's log of what? That's addition, so it's got to be multiplication minus log of b to the fourth, right? Now you have subtraction, but subtraction is really what? Division. Log of, what goes on top? 3a squared. What goes on the bottom? b to the fourth. So you're taking the log of that. If you expanded it, you'd go back to this. If you condense it, you go here. Expand it here, condense it here. The word condense means make it smaller, expand, make it longer. Good? Okay, there's only one more thing to do, and that is, oh, I'm sorry, there's two more things. Okay, here's another one. Given the fact that if you have two logs equal to each other, log of u base A equals log of v base A. If your bases are identical, base A, what do you know about the two numbers you're taking the log of? They got to be what? The same thing. U must equal v. Well, write the following equation right here without any logarithm. I want all logs to go away. Hint, hint, make this equation look like that equation, and guess what? All the logs go away. Go. Log of y equals, I want it to equal just one log, not two logs. This will be log of what? 3x. Because it's addition, it becomes multiplication. Okay, are the bases the same here? What is the base? How'd you know it's 10? There's no base given, it's base what? 10, that's called the common log. So what do we know now? Y equals what? 3x. Y has to equal 3x in order for these two to be equal. Good? Okay, so here comes just a quick blanket statement they make. What is it? What is the change of base formula? Well, it's you changing the base is what it is. And here's what it says. If you're given the log of a number m base what? A, and you don't know the answer, you guys can change the base to anything you want, but guess what two bases you want to change them to?
E or 10.
What?
E or 10.
E or 10. Why E or 10?
Because
Because
that's what's in your calculator.
that's what your calculator's programmed to do. So why wouldn't we want the base to be what? Base what? 10. Or base what? E. Either one of these works. Now here's how you do it. Once you say I don't know the answer, you say, well, I'll just change it to base 10 or base E. I'll just do this. Log of m base 10. And then underneath it's got to be, whoops, sorry, wrong one. Log of what? A. Whatever the base is here, it's on the bottom. Whatever the number you're taking the log of is on the top. That's it. That's all it is. So if I gave you this, what is the log of 7 base 2? Can anybody do that in your head? Can you tell me the answer? In your head, can you do it? 2 to what power is 7?
Third 7.
I know 2 to the third is 8. I don't know. So because I don't know this, question mark, I don't know, I'm going to change the base. So how would you change the base out of this? Log of what? Log of? No. You're gonna go to base 10. Don't say log of, don't say base 10. Just say log of what? 7. The top number goes on top. The base will go where? On the bottom. And you are now in what? What base are you in right now? You're in base 10. And why did you do that? Because your calculator is programmed in base 10. Type it in right now. Tell me the answer. I know 2 cubed is 8, so I know it's close to 3.
2.8.
Give me more. 2.807.
807.
Okay, gotcha. How do you know you're right? You know you're right.
The calculator.
Well, how does it make sense?
2 cubed is 8, and 8 is close to 7.
And 8 is close to 7. How about the fact that you just told me the answer is this? Couldn't you just take this, put it right there? Couldn't you just put it right here? 2.807. Okay, 2 to the what? 2 to the 2.807 should be what? 7. Type it in. Guys, make sure this makes sense to you. Don't just accept an answer. Is it close to 7? Like 6.999? Are you typing it in? Okay, yeah. All right. Now, if you don't want to type it in, you don't have to. But that you're trusting your calculator. Okay. Here are 2 ways to do it. When you do the change the base formula, most people do base what? 10, base 10, or base what? E base E. I don't care which way you do it, they both work. So would you do this one right here, both ways. Do it base 10, and then do it base E, and prove to yourself it works both ways. This problem is kind of messed up looking. I'm going to rewrite it. This is what it says. Log base E of 8. What's the answer? Katie, give me one way you wrote it. Just one way.
8 over
Log what?
3.
What's the answer?
1.893.
893? Okay. Is she right?
Yeah.
Well, the only way I'd really know if she's right is to do this. Take the number 3, raise it to the 1.893. Do you get roughly what? Oh yeah, I'm sorry, it's 8. It's 8, my fault. Do you roughly get 8?
Yes.
Yeah? Okay. Now there's another way to do it. You don't have to do common log, base 10, base 10. Chris, how did you do it?
I did
Okay, ln of 8 over ln of what? 3. Do you still get 1.893? Okay. You guys, I would do it. Don't trust me. I know I put the answers up here, but you guys should not trust me. Type this stuff in. Part of the process here is you typing away, because if you can't type this in on your homework, you're going to get these wrong. Because I see half of you wait for the other students to get the answer. I guess that's okay, but it's all about repetitive. Keep doing it, you get them right, Okay? I'm done. That's it. Are we okay? Property's fine? Properties they'll start out easy, but they'll get what? They're gonna get hard on you, okay?